Alright, so this is a really good problem. Kind of brings everything that we've done in this worksheet together here. So it says one side of a rectangle is twice as long as the other, and the rectangle's area is 80 square units. Draw the rectangle on the grid so that each of its vertices lies on a dot. So those are the lattice points, right? We call that. So let's take a look. Before I'm going to jump into this thing, I'm going to go ahead and just sketch a rectangle down here. So I've got a rectangle. Doesn't matter how accurate it is here, but I know that one side is going to be twice as long as the other, and I know that the area of the whole thing is going to be that 80 square units. Right? So to find the area of a rectangle, it's going to be the length times the width. So I can just do x times 2x, and that's going to be equal to that 80. Right? So I want to find out what the lengths of those sides are. So to make that happen here, x times 2x is going to be 2x squared, right? Equals to 80. So I want to isolate x, so I'm going to divide both sides by 2. So I end up with x squared equals to 40. Right? But I want x by itself, not x squared, so I'm going to take the square root of both sides. Now technically it should be plus or minus, but we're talking about distances, so we'll just go ahead and use the positive version. So remember, square root of 40 can be broken down into square root of 4 times square root of 10. And I went with square root of 4 and square root of 10 because square root of 4 is a perfect square, meaning that if I took the square root of it, it's going to be an integer value. So in the end, I end up with 2 root 10 as my value of x. So I'm going to draw that over here. So 2 square root of 10. That means that the longer side is going to be 4 square root of 10 because it's twice as long. Right? So the question now becomes, how do I create a side length that is has a length of 2 root 10? Well, earlier in this worksheet, we've seen situations where if we have a right triangle, in this case, let's say that I have square root of 10 for the side length. So we've got to think of what squared plus what squared is going to be 10. Right? So you can think through it, but 3 and 1 is a combination that works for this thing. So if I do this as 1 and this is 3, that'll give me that length for the hypotenuse of square root of 10. Okay? But the reality for this question was we wanted to find 2 root 10. So I can use that same idea we've done previously to think about just a bigger version of that and do this as 2 square root of 10 for the hypotenuse, which means that I would just go ahead and double the other side lengths. So that'll get me the smaller side, which means that if I kind of just extend that to another right triangle with a hypotenuse of 4 root 10, that means that I could double those dimensions again. Right? So I need to come up with a rectangle whose side lengths consist of those two combinations there. Right? So for this thing, when I go back up here to my diagram, or the big grid that we have here, I want to think about this as, let's see, I want to go ahead and find a 2 root 10 and a 4 root 10. Right? So that means that I want to have dimensions of 6 and 2. Right? So if I go here and I count down from the top corner here, 1, 2, 3, 4, 5, 6, and up here I go over 1, 1, 2. So I can go ahead and connect those things. Hopefully use a ruler and it's better than mine. But that makes it a 6 by 2 for triangle, or you can think about it as going up 1, 2, 3 and over 1, and then doing that same thing again. Right? Because two of those triangles with the dimensions of the legs of 3 and 1. Right? So that's going to give me the shorter side. Now I need the longer side. The longer side was formed by triangles that were 12 by 4, so 12 by 4. So in this case, remember, we want these sides to be perpendicular so they form a right angle there. So that means that if I went with the long side, so the 12 and then over 4, it's not really going to get me what I want. But if I go down 1, 2, 3, 4 units out and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's going to get me to a better place. This will be a harder one to draw. Let's see if I can make this work. That's pretty good. So that's going to be a 12 by 4. And you can also see that once again, for a little bit better here, maybe I can draw a different color. I can see that this is going to be a 1 by 3, a 1 by 3, and another one, 1 by 3, and a final 1 by 3. Right? So that'll get me that 4 root 10. And so I've got two of the sides here. I can go ahead and do that same process again, or I can just go from this new corner in the bottom right to go up 6 and to the right 2 to be the same thing. So 1, 2, 3, 4, 5, 6, and over 2. So I can draw that in, and now I just connect those final vertices there. So it looks something like that. Okay. So tough problem, but definitely doable. Okay, hope this helps.